that's the basic, circle and circle shape. The other one, shapes, it's useful because we use it, well, to draw stuff, obviously, but also that's how a lot of collision detection gets done. So there's actually a lot of different kinds of rectangle shapes. So if you actually, there's like int rect, is like an integer-sided rectangle, which they use for bounding boxes. Same thing with float rect. Okay, but we want to use rectangle shape for right now. Couple of different reasons for that, but for the most part, this is the one that we can make a shape, put textures onto, and do a few things. The other ones are more like data oriented. So here we go. I'm going to call it my rect, and I'm going to give it a vector 2f, and I'm going to make it 50 and 200. Okay, and then I am going to put down here draw my rectangle, which little editing error, it popped up magically. So we give that a little run, and oops, I should call it my rectangle to match up. Okay, so notice just like this, I gave it some dimensions, it drew it up in the corner, and then I can. Okay, so I'm drawing our rectangle here, and I just want to talk about the difference between move and the move command and the set position command. So the move command is kind of interesting because it moves relative to the place that it started off with. So this rectangle started off in the 50, 200, and it started in the upper left-hand origin of the screen, and I'm saying, hey, let's just move it 1 pixel, which turns out to be not particularly interesting. You can see that it bumped it like 1 pixel from the edge there. Great. But if we take this vector 2f or not vector 2f, we take this move command and we do it right before we actually draw the rectangle inside the loop. I haven't really talked about this too much, but what's going on with this loop is it's kind of constantly, while the window stays open, it clears the screen, redraws everything, displays it. Clears the screen, redraws it, the screen. That's how it's going. And that's how, like, if I grab this window and I drag it around, that's why everything like kind of stays written on the screen, is because it's constantly refreshing. And you guys have seen stuff like the refresh rates on your monitor and things like that. Those are all helping your computer draw things as quickly and as clearly as possible. So if I take this and I change the move there, let's see what happens. Whoa, wait a second, what happened? So you see that the little white rectangle shot off the screen. It's actually still shooting off even further off the screen. So what happened is that I moved it really fast. It's going through this loop really, really fast. So if I kind of artificially slow it down and say, hey, let's move a 100th of a pixel every time, and give this a little run, you'll notice we get this kind of, animation going on, which is cool because we're going to love to animate stuff with graphics. I mean, that's one of the primary things that we're going to want to do, and it's nice to be able to animate stuff with arithmetic. But so moving is saying, hey, what was my last position? Okay, scoot it over a little bit. Now, it turns out this is kind of an awkward way to move stuff because, well, on my computer, which is pretty fast, going through 0.01 pixels a second has it move at sort of a nice pace. But on maybe some of the school computers, which are kind of awful, it would just crawl. It would barely move at all, because the difference in the speeds in the computer. So what if we want it to kind of do its best to move 1 pixel a second or 1 pixel at a time as this program runs? So if we go in here, we can actually set a frame rate limit that says only update the screen 60 times a second. And we see that statistic a lot with our graphics cards and things like that. Hey, let's guarantee it to move 60 frames a second. So you can see how fast that moves across the screen. If I slow it down and say you may only update this 30 frames a second, you'll see that it moves noticeably slower. Okay, and that's going to be something that's very useful if you're making a game, you want to dictate how fast or how slow things should work on lots of different computers. Setting the frame rate limit will get you a lot of consistency. Okay, there's a little bit of I'll say debate about whether using the move command, which is relative to its current position, or calculating its exact position and then using set position to say, hey, I'm going to change this vector and then I'm going to set it exactly to where I want it to go. Typically, I find it, if you have very simple stuff, using the move command is great. I move back and forth, I do this. If you're doing something where you're actually calculating like a little physics or stuff's going to bump into each other, a lot of times calculating the proper position and setting it there makes more sense because knowing how it's going to move probably involves some calculation. So you got a little choice there. So hopefully this was all pretty useful, guys. I will catch you later. Bye.